very much. Good afternoon, everybody from Japan. In today's session, well, it was meant to be Peter and I, but unfortunately, Peter has a rather sore throat, so I'll be doing the entire presentation instead of just my bit. So please bear with me. He is here as well, and he's willing to answer questions at the end, possibly via swap card instead of vocally, but I'm sure you get the idea. Anyway, let's make a start. So today we're going to talk about why we killed Riak Search and what we're doing instead. So let's go on. What are we actually going to talk about? So I'm going to read my slides for the moment because it's a contents page. Introduction, tell you what we're doing, stroke of genius, ideas on going about searching, thinking big, stuff needs to scale. If not primary and secondary, no more excuses on why you shouldn't do stuff. And finally, opening up with search going forwards. If you're wondering why I'm slightly rushed, this is originally a 40-minute talk. We're trying to squeeze it into 20 minutes. So I'm afraid everybody will have to try and keep up. So, quick introduction. Who are we? Peter and myself, we are the heads of TI Tokyo. We have over 60 years of combined IT experience between us. We've supported Riak from 2016 onwards, starting working for Basho, taking over their APAC support. We helped co-found OpenRiak, which we actually announced at Codebeam Europe this time last year, which is co-founded fully open source under the EEF. We are directly involved in shaping OpenRiak's future. We make packages, we make documentation, we work with the other collaborators and do our best to try and make things as well as we can. So for anybody here who's not aware of it, distributed system, OpenRiak, or Riak as it was then, is a distributed system. They run on multiple machines simultaneously. Data is shared between machines, usually sharded first. Usually you can store multiple copies of data, so if one machine goes down, you can still keep running with the others. They usually have ability to scale, commonly horizontally and vertically, i.e. you can add more boxes, or you can just make your currently boxes bigger. Of course, because you're using many boxes in parallel, you have the ability to process vast amounts of data. And they're used by many different types of businesses, such as financial institutions, government organizations, e-commerce, manufacturing, messaging, IoT. I mean, the chances are you've actually used a system that runs Riak or OpenRiak within the last 24 hours and haven't even realized. So going on to actually talk about search now. The problem that we originally encountered was that NoSQL, which is this kind of database, is great for direct queries. Get me that. I want to know this user and their email address. Perfect. Easy to get because it's a direct query. We have the entire string. We can also do some range-based searches. For example, find me everything from 2025. That's generally doable. What will that be between the end of 2023 and the start of 2026? You get the idea. However, wildcard searches, this is the classic SQL one where SQL really has a strong lead over us, such as select something where item like Bob. So if Bob is somewhere within whatever field we're searching for, then it's a hit. Otherwise, it's a miss. And in NoSQL, that is insanely hard to do without using ridiculous amounts of resources, which is why we try not to do it. But people want that functionality, so what should we do? So we thought, well, we've already got this awesome database. How can we improve on it? So reinventing the wheel, basically trying to import SQL into Riak is probably not a very clever idea, as that's take forever. Instead, we need a search that scales nicely. So we had a look around with one that can be open source, that we can work with it, and we found Apache Solr. No, it's a fully open source product. It's a popular search engine. Sounds great. So we're going to stick it into Riak. We're going to take these two open source products and squish them together. They're going to have to share the same code base, but we're going to call it Riak Search. Or actually, we're going to call it Yokozuna because that's actually kind of cooler name and it's more with the Riak and Japanese themey thing. But we're going to go with that anyway. So we then want to have our wonderful idea. We've got Solr, we've got Riak. It's all squished together and it's great. And we need to think about how this goes when it gets bigger. So we have different parts of our application and they work together. We have Riak, which is cool, and then we have Solr, which is also a nice engine. And when you stick the two of them together, your data becomes super data because you can store huge amounts of it and it's really easy to query. Sound good? Yep, we thought so too. Except It's not always. For the moment, let's think about how it goes. So we have Riak KV, we have Solr, they work together as a nice little pattern. So for people who aren't familiar with Solr, it stores an index and then it goes through and indexes specific data as you store it. So now we've got our setup, we say, let's go and store stuff. So we're going to store things such as a first name, a family name, date of birth, reference ID, contact, maybe even a counter. We can store all kinds of different stuff in the indexes. And it's great. I mean, Solr stores all the indexes in RAM, so it's really, really fast. It finds the right index, it goes off and says, hey, Riak, give me this. And Riak says, yeah, here you are. And it's great. Everything works. Except when it doesn't. And this example is based on one of our customers. So let's say you make a tiny typo in the schema for the counter. So we've, been storing data, and every time you store data, the counter in Solr will throw a tiny little error that causes a 1 millisecond delay. And that sounds pretty harmless. I mean, this is the same with our customer. Despite being told about it in 2015 and reminded regularly, they still hadn't fixed it in 2024. However, at this point, they decided that they would migrate all their customers from individual on-site setups to a centralized system they run. I mean, after all, SAP did it. I mean, they make money hand over fist, and their software is so great and easy to use. Why can't they copy this excellent example? So suddenly they discovered that this 1 millisecond delay, when hit with 100,000 writes, becomes noticeable enough to cause a timeout. Now, remember, they were migrating all their clients from individual setups to a centralized setup. So 10,000 writes is a drop in the ocean of the wave of data that's hitting them. So that little counter we have there essentially turns into a tiny delay. And then you multiply that by 10,000 and then by 10,000 and maybe by another 40, 50 million. And suddenly the whole thing grinds to a halt and we have a system outage and senior management is on the phone to us saying, what is going wrong? And this is why you need to be very careful when things sell. But on top of that, the Java VM is busy trying to take as much memory as possible for itself, which makes it in constant competition with the Erlang VM doing the same. I mean, even if they hadn't got this typo in their schema, they'd still run into similar problems because we're talking about the setup. They've got 9 boxes with 96 gig of data, sorry, 96 gig of RAM a box. And with only 2 terabytes of data shared over all of that, they're still encountering issues and memory things and stuff falling over because it just scales badly. So we worked hard on this. I mean, despite attempts on Solr to improve it, including from moving from version 4 to version 6, we were never able to overcome the constant resource contention between the Java VM and Erlang. I mean, Solr keeps all its indexes in RAM, so it needs a lot of memory. But even when you distribute it, each individual Solr instance needs to keep the indices for the entire data set in RAM. So of course, that means that it requires a lot of memory and it scales very, very badly because the more you scale Riak horizontally, the bigger the chunk of memory Solr needs to keep an index of everything per node, which is insane. So, when Riak can't scale properly with Solr eating this much memory and there's nothing else we can do, it's time for us to get out there and kill it. And that's exactly what we did. Which then gives us a conundrum. We no longer have a search. So how else can we do this? So all we want is the value or values. Within Riak, the standard way to store stuff is bucket type, buckets plus key. So, you could have a default bucket type because that's standard. You have a username email bucket and a username called key called username, and that will return email. And then maybe you have another bucket, default bucket, and then bucket name is email username, key is email, and that will return username. That may sound somewhat confusing at first, but it's a simple way to solve stuff. If you only have 2 pieces of data, it's actually quicker just to duplicate it like that. A can fetch B, or B can fetch A by just having one copy of AB and one copy of BA. And that will allow you to get your data quickly. So essentially, we've kind of got through our search if it's a direct phrase search, but still it leaves us a bit vulnerable to wildcards and other issues like that. But of course, that requires extra rights at client level. And if you have much more fields, for example, a full username, email address, hashed passwords, address first line, second line, da 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 da, you need to duplicate a ridiculous amount of data, which just isn't going to be practical. And the worst case is that if the application crashes partway through the writes, then you're going to end up with a partial write, and you don't know what user data you have and don't have, and you're in real trouble. So we thought, nah, it's not going to work. What else can we do? So maybe if we store indices via metadata when we write, we can actually achieve something more with this. That allows one write to achieve multiple indexes to be stored at the same time. And in the same way, a single read of the index will now return a list of matching keys, which we then return straight back to the client, i.e. one search via the index will give you all the answers to the data within that set. Which means, again, we can group query or range query with this. And if we look at it, it's actually quite simply set up. We have primary indexes we discussed a minute ago, which is bucket type plus key. And we have a whole new bunch of indexes, which are queried in exactly the same way with bucket type plus index. And the index then returns the value of all the keys that match. That can mean we can do a query for who attended CodeBeam 2025 in Europe, because we have CodeBeam 2025 as the conference name, as conference index. Or maybe we did who came in November 2025. We just do a search between October 31st and December the 1st, and anything between that range will be found. But of course, the classic one is, what should we call it? And being the really original people we are, we called it secondary indexes because that's the standard name for it everywhere. But we can also call it 2i if we want to. Anyway, why don't enough people use Riak? This is a question that we keep banging our heads against. There was bad news about it. Basho went bankrupt. Fair enough. Life is bad. But how do we get more people into it? Because, even with Basho going bankrupt, the original creator of Riak, now we're OpenRiak with a fully open source version. Essentially, we're free for anybody to use. We may not have a marketing team, but still, we'd like to get the word out there. But people resist. I mean, the classic one is, I don't use React because I don't understand Erlang. To be honest, you don't need to. When I started in this job, I didn't know Erlang. I'd never heard of it, but I was able to talk to Riak, and that was just using PHP. Again, many people say we can't talk to it because I only know such and such a programming language. I mean, Python, Net, Rust, Elixir, etc. Well, guess what? There's already a client in your language, so that's not a valid excuse. Another one, I don't know how to query OpenRiak. Well, as everybody here saw a second ago, bucket type, bucket key, or bucket type, bucket index. That's not exactly rocket science, is it? We all saw how it works. Everybody here can probably do that. And you can even query it like that from the command line with curl. But again, there keep be more excuses. I mean, it take me too long to learn a new way to query. We just saw how hard it is. And as I said, you can test with curl or wget. The next one was actually a good excuse. I need DynamoDB style queries for my application to work. And that's a fair point. We had to stop and think about this one. But we thought, and we looked back and said, well, we've already re-implemented S3 in OpenRiak CS, and that's been working for years. So what if we then re-implement DynamoDB's query filters in OpenRiak KV? What? Can you do that? Well, we look back at this. OpenRiak CS has opened S3 compatibility for over a decade. That pretty much means that almost any S3 application can just be repointed at OpenRiak CS, and it works as if it was talking straight to AWS by itself. Amazon's S3 storage by itself. So why can't we do that again? I mean, and that's exactly what we did. We are now implementing DynamoDB's query filters within OpenRiak. And that gives us two key things. First of all, DynamoDB developers can get up to speed quickly because they already know how to read and write to the database. It may be OpenRiak and not DynamoDB, but hey, if I can query it the same way, who cares? I just have to point it at the right place. And the other thing that's really important is migration will then become much easier for people to move from DynamoDB to OpenRiak. And that gives you all kinds of wonderful things. I mean, obvious ones are cost saving, compliance, but also uptime. I mean, DynamoDB claims 3 nines uptime, but based on the outage the other day, they didn't even achieve that. But some people say this still isn't enough. What else can we do? We need to bring back some kind of deeper search, similar to what we had in Solr. So we thought, let's open up search. Let's go further. I mean, the problem is NoSQL's search capacities are limited, especially wildcard searches, as we talked about right from the start. So it's without that kind of flexibility, how can we implement a powerful search? You really want to be able to dig down into your data and retrieve certain stuff within whatever condition. And another one that's very popular today, let's say you want to use OpenRiak as a vector database. I mean, maybe you need it for AI model data lakes or training or whatever. Can you do this in OpenRiak as it is? And the answer is, well, basically, you can't. It's just not going to happen. No SQL database like OpenRiak doesn't do that. So what do we do? Well, we go out and we ask for a little help from our friends. So we look on the market and we find that Retrievalist tried with Solr, but it wouldn't scale properly as part of OpenRiak. So how do we what lessons did we learn from that? Well, if we integrate it directly with Riak and then make them depend on each other, that causes problems. So we need something we can keep at arm's length, but is a good, reliable open source search platform. So what about OpenSearch? I mean, OpenSearch is a great system, but it does suffer with a data storage at very, very large scale. So if we were to set it up and then have OpenSearch and OpenRiak and then duplicate the data between them, that would also be hugely inefficient, especially as OpenRiak stores data better than OpenSearch does. So that's not going to work. What else can we do? So we sat and we pondered, and we thought, well, maybe we should go hybrid. So as I said, OpenRiak KV is a NoSQL database that scales extremely well, but is very limited in search capacity. Well, somewhat limited with the new stuff, but still, it's not the most awesome thing on the block. And on the flip side, OpenSearch is a great search engine, but it does suffer when storing data at extremely large scale. So how about if we stored all the data in OpenRiak, but stored the indexes in OpenSearch and just had the two play ball with each other? I mean, OpenRiak's next-gen REPL features a reconciliation engine we can talk to. So now, if we write an OpenSearch module that talks to that for storage, we can then store the data in OpenRiak and enjoy OpenRiak's benefits of massive scalability that's stable and fast. But at the same time as the indices only are stored in OpenSearch, we avoid all the scaling issues they have at massive scale with data because it's only doing indexes, which means, first of all, it's faster. And secondly, it only searches the local indices and then retrieves whichever keys are relevant directly from OpenRiak, which gives you a really fast return on your question. And that is a very impressive way to scale things going forward and give interoperability that we were looking for originally with OpenRiak and Solr when we started. Now, as I mentioned, time is limited, so I'm going to have to wrap up now quickly. So today we talked about briefly an introduction to OpenRiak, distributed databases. What do we do? We talked about adding search, namely Apache Solr, which is a great idea, but the problem is it didn't work at scale, so sadly we had to kill it. So then we work back to the simpler one, secondary indexes. It doesn't give us the same level of power as Apache Solr, but it is quick, it's simple, and it works straight out the box. It's built directly into Riak. We then talked about adding DynamoDB search filters into OpenRiak to make it much easier for people who are familiar with DynamoDB style queries to actually use Riak and maybe even switch from DynamoDB to OpenRiak to save them a shed load of money with better performance and reliability. And finally, we talked about opening up search, where we add OpenSearch to talk to Riak via the reconciliation engine and allow people to enjoy the best of both worlds with great storage and a great query engine that they can find easy documentation on how to use anywhere. Anyway, I'm afraid I had to run through this very, very quickly. I'd like to open the floor very soon to questions and answers. Very briefly, if you need to contact us, this is myself, this is Peter. This is the OpenRiak community. Please feel to join, sign up, talk to people. It's a fun place. Websites where you can find more information. If you need enterprise-grade support, this is who you contact. If you want to download binaries and go and play with OpenRiak yourself, this is the place to go. And finally, there is the thing to rank us on Sessionize, the QR code for the post-React group, and the GitHub repo for OpenRiak. So everybody, I'd like to say thank you for your time. I know it's been a slightly rushed talk, but I'd like to open the floor to questions.
Thank you. Questions? Okay, I'll throw one out there. So with provisioning, data in Riak Search was co-located on the nodes, correct? So if I need to scale OpenSearch and OpenKV or Riak KV, what are the sorts of like ratios you're saying in terms of overhead, in scaling number of nodes or machines, resources? Is there any example you can throw out there that's concrete?
Right. Well, this is very much down to your personal needs. So OpenRiak is incredibly flexible. I have a cluster that runs on Raspberry Pis just on the other side of this room, for example. But of course, there are some of the major players in the business who run it on hundreds of servers in parallel. And it's absolutely huge and they store ridiculous amounts of data. For OpenSearch, as you're only storing the indices in OpenSearch, you don't actually need to be that have such powerful boxes for that, as the data is all stored in OpenRiak. And as such, you'll be able to scale OpenRiak as much as or as little as you want. And provided that as OpenSearch is not integrated within the same box as OpenRiak, instead it sits on a completely separate box that talks to it, then it allows you to run the two boxes independent of each other and avoid the issues we had before with Solr and with a Java VM competing for resources with the Erlang VM, which is running OpenRiak.
Yeah, I was curious on the
Does
ratio
that help answer
between
your question?
index overhead versus the data overhead.
Yes, the
How much
index
smaller is it?
overhead on OpenSearch is much, much lower as it doesn't need to worry about data at all anymore.
Yeah, what kind of
I'm
ratio is
afraid I
that?
can't give you exact numbers because it's
Okay.
currently development in progress. But the initial tests that we've seen, it seems to be performing reasonably well.
Okay, great. I'll check it out. Thank you.